Hi everybody. I just wanted to give you a brief rundown on the row matching using for optimization of state machines. What we've done here is we've got a present state next state diagram, and what I wanted to do in here is a little bit of row matching. The key to row matching is that outputs have to be the same for rows to be equivalent, as well as the next states. So when you look at the outputs for this particular state machine, we see 0, 1, 0, 0. And so now we look for AB. Could it be the same as row B over in here? And the answer is no, because the outputs are different. In fact, trivial row matching prevents B from being equal to C. C might be equal to D, but we don't really know. Had the outputs been the same, if they had been both 0 on output with a 1 on the output here on row D, we could have done some row matching, but right now row matching doesn't show us anything, so we use instead what's called the implicant chart. The implicant chart starts with the second letter, B, and runs down the axis B, C, D, and then it starts with the first letter and ends with the second to last letter, A, B, C. The basic idea is you're going to make a lower triangular matrix. And then you do a row-wise comparison. And one thing you might like to do is compare A with B. A and B will be equal if A and D are equal, or if B and C are equal. But we see they're not equal because right away the outputs are different, so we can trivially eliminate them. In fact, A might be equal to D, A might be equal to C, but we don't really know unless we trail it down, and we'll show how to do that in a moment. But let's do the trivial outputs that can be eliminated when the outputs are different. So let's look at B, C, B, D. These have different outputs, therefore they can be eliminated. They can't be equivalent. So we're looking for equivalence, row equivalence. So now let's look at AC. From A to C we have AD. From A to C we also have BC. But we know BC is not equivalent, therefore we remove it. From A to D we have AA, that's equivalent, and BD. But we know BD is not equivalent, so we remove it. Now from A to, from C to D, we have DA, and we know that's not equivalent. So this is already in a row minimal form. And so this is a minimal finite state machine. And that's how you do the implicant charts. If you can find things that are equivalent, then you should be able to reduce some of the rows out. But in this particular case, we were not able to. And that's my example. Thank you.